guys, so for today's video, I'm going to answer all the activities in chapter 7, IP addressing. So let's start answering the first activity. In this activity, we're going to convert binary to decimal. Instruction: this activity allows you to practice 8-bit binary to decimal conversion as much as necessary. We recommend that you work with this tool until you are able to do the conversion without error. Convert the binary number shown in the octet to its decimal value. Excuse me. Let's start. So the given is 0, 0, 0, 0, 0, 0, 1, and 1. So in binary, we use 2, 2, then the exponent is 1, then and so on. So the value of the first bit is 1 because 2 raised to 0 is 1, not 0. Then 2 raised to 1 is 2. 2 times 2, 4. Then 2 times 2 times 2 is 8. 2 times 2 times 2 times 2 is 16, and so on. So let's start. In first bit, it is 1 because there is a this is the given, so 1 and 1. The position is 1 and 2, so you need to plus 1 and 2. It will be, the answer is 3. So let's try if it is correct. So this is correct. Let's try another number. So the position of the bit is in 32, 16, and 8. So we need to add 32 plus 16 plus 8. So 32 plus 16 is equal to 48. Plus 8 is 56. Let's check. So this is correct. Let's try another one. So 64. We need to add 64 plus 16 plus 8 plus 2. Then the answer is 90. So it's correct again. So let's try another activity. So in the next activity, it is conversion vice versa in the first activity. In first activity, we convert binary to decimal, but now we're going to convert decimal to binary. Let's start. This activity allows you to practice decimal conversion to 8-bit binary values. We recommend that you work with this tool until you're able to do the conversions without error. Convert the decimal number shown in the decimal value row to its binary bits. Let's start. So the given decimal value is 83. So we need to identify whether it is less than or greater than in the bit. So 83, 64 is included because it is less than 83. So we need to minus 83 to 64, so we can identify faster the value. So 83 minus 64 is equal to 19. So 32 and 16 is not included. So wait, 128 is 0, then 32 is 0 again, 16 is 0. Then let's try 8 plus 4 is equal to 12. So 1 plus 1. So we have a value of 12. So we need to minus 19 to 12. 19 minus 12 is 7. Oh wait, this is 0. Sorry, that's 16 is included. Sorry. So because 19 is greater than 16, so 16 is included. So 64 plus 16 is 80. So we just need 3. So 8 is not, 4 is not also included. So 2 and 1 is included because 2 plus 1 is 3. Let's check. Okay, it's correct. Let's try another given. Let's try some bigger number. Yes. So the given is 239. Then 128 is included because 128 is less than 239. So 239 minus 12 minus 128 is 111. So 64 is included. So 128, 64 is 192. So we just need 47. So 32 is included. 128 plus 64 is 224. We just need 15. So 16 is not included. So if you add 8 plus 4, it is 12. Plus 2 is 14 plus 1 is 15. So all of these are included. Let's check if it is correct. So this is correct. Let's try another number. Last. So 61. So 64 is not included because it is greater than 61. Also 128. So 32 is included because it is less than 61. So 61 minus 32 is 29. So 32 plus 16 is 48. So 16 is included. Then 8 plus 4 is 12. Then 2 is 0. And then 1 is included because 32 plus 16 is 48. Plus 8 is 56. Plus 4 is 60 plus 1 is 61. So let's check. It's correct. So let's move on to another activity. So in this activity, it's about ending to determine the network address. So it is just in mathematics wherein you need to use truth table because if the given is true, the answer will be true. Then the given is true or false or vice versa, the answer will be false. Because if you are using and, it is considered as false, but if you are using or, it is considered as true. So If it is false and false, the answer will be false. Okay, let's start. Instructions. Use the ending process to determine the network address in binary and decimal formats. So first, we need to assert network address in binary. So if the given is 0 and 1, it will be 0, then also 0, 0, and 0. Then both 1, it will become 1, then 0, 1, 0. Next is 0 for ones, then 0, 0, then 1. Next, 0, then 0 and 0, it will be 0 because like in truth table, false and false is false. So 0, 0, then 1 and 0 is 0, 0, 0. Next, if we saw the given is all 0, the answer will be 0 because there is no 1, so it is all 0. Okay, let's answer. So this is 10 because 1, 2, 4, 8. So 2 plus 8 is 10. Then next, 32 plus 64 plus 32. 64 plus 32 plus 16 plus 8 plus 1. The answer is 121. And this is 0 because there's no value. Then 0. Let's check. Okay, this is correct. Let's try another activity. Another given, sorry. So, okay. This is 1, 0, 1, 0, 1, 1, 0, 0. Then 0, 0, 0, 1, 0, 1, 1, 1. Then 0, 0. Next is all 0. The answer is 128 plus 32 plus 64, 32, 16 plus 8 plus 4 is equal to 172. Then 1 plus 2 plus 4, 8 plus 16, 23. Then this is all 0 again. Let's check. Okay, this is correct. Okay, let's move on to another activity because there are a lot of activities in chapter 7. Okay. So in this activity, we need to know if it is unicast, broadcast, or multicast. Instructions. Click Start to view the destination IP address. Next, click the host, which will receive a packet based on the address type, unicast, broadcast, or multicast. This is a timed activity. Okay, let's start. So the given is 192.168. Okay. 100.2. This is PC. Okay. Let's try another. Let's wait for it. Wait. already answered this, so let's reset. Okay. 225.5.77.126. These two. Because this is A. 225.5.7.126, so this is the same. Okay, this one is this. Okay. Okay, let's move on to another activity. So in this activity, it is about pass or block IPv4 address. Instructions. Decide to pass or block each IP address depending on whether it is public, the internet, or private small local network. Click Start to begin and click on either pass or block. Okay, we're going to identify if it is public or private. Let's start. This pass. This pass also. This pass. This pass also. Okay, it's correct. And this all the IP addresses given in this activity are all public because it is not a small local network. Like the private addresses are like 10, 172, and then 192. Let's try another activity. This block because it is 10. Pass. Block. Okay, sorry. Wait. Pass. Pass. Let's try again. Wait. This block. Block. Okay. So as you see in this given, there are private or small local network because it is not the internet or the public because they're given like 10, 192. So let's move on to another activity. In this activity, it is just like related in the last activity, the public and the private. Okay, let's start. Instruction. Drag each IP address to the correct category, public or private. First, 172, it is a private IPv4 address. Also, it is 192.168.3.5. Then this one is a public IPv4 address. Also, this one. And then all of these given are private IPv4 addresses. Okay, let's check. It's correct. So the public addresses are just the 192.0.3.15 and so on. Then the private addresses are starting in 172, 192, and 10. As you see, 192, there is also 192 in public. It is a public because it is not considered as private because in this private address, the given is 192.168. Okay, let's try another activity. IPv4 issues and solutions. Instruction. Drag the IPv4 and the IPv6 terms to the field next to the appropriate description. Okay, let's start. Description. 128-bit address / 340 antecillion addresses or 340 antecillion addresses. It is a IPv6 because an IPv6 uses 128-bit address, while the IPv4 uses 32-bit address or 4.3 billion addresses. IPv4 is smaller than IPv6. Next, transports an IPv6 packet over IPv4 networks. It is a tunneling because it in this lesson, the IPv6 transports to IPv4 or the tunnel, then goes to another IPv6. That is the tunneling. Then next, uses NAT64 to convert between IPv6 and IPv4. It is translation. NAT64 is a translation. It uses to convert IPv6 and IPv4. In IPv4, or the private addresses in IPv4, we use NAT to convert those private addresses into a public addresses. Next, allows IPv4 and IPv6 to coexist on the same network segment. This is a dual stack. So a dual stack, IPv4 and IPv6 are in the same network, or it is a together, or okay, let's try. So these are correct. Let's go to another activity. In this activity, it is practicing IPv6 address representations. Instructions. Convert the IPv6 addresses into short or omit the leading zeros and compress forms. Use the numbers at the bottom of the page to continue this activity. So there are 10 activity are given in this activity. So first, IPv6 conversion. So this is 2001, then 0, then BB8. So sorry if there is a given answer because I already tried this activity. I cannot clear this answer, but I know the answer. So this is 1, this is 0, 0, 0, then 2, 0, 0. Okay. Why in this omitted the zeros, in 2001 there is no zero in the leading zero, or there's no leading zero before the 2. Then in next 0, 0, 0, there are 3 leading zeros, so we need to just include 1. Then next is DB8 because there is a leading zero in the before that letter D, and then so on. So compressed format is 2001, then 0, DB8, then 111. Then we can use the double colon here because there are a lot of given zeros. So then 200. Let's check. Wait. Okay, I forgot to use a colon here. Okay, it is correct. Next is 2013, 0, then 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, then C, D, E, F, 0, and then 1. Then 2013, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. Then we can use double colon again. Then 1. Okay, it's correct. Next, figure 3. Oh. So these are all 0 except the last preferred form, the last given is 1 because there are 3 leading zeros but there is a 1 in the last part, so it's correct. So there are a lot of zeros, so we can just use a double colon to compress it, then 1 is correct. Next, figure 4. 2012, A, B, C, D, E, F, 0, 1. As you see, there is a 0 in this answer, but the 0 is inside the given. It should be in the first part because it will be excluded. So this is 2, 3, 4, 5, then 6, 7, 8, 9, 1, 0, then all A, B. Okay, 2012, A, B, C, D, 2, 3, 4, 5, then 6, 7, 8, 9, 1, 0, then 4 A's, then 4 B's. Okay, it's correct. Figure 5. So there is an answer again, but I'm going to answer it again. A, B, 1, A, 2, B, 0, 0, then 0, 1, 2, 3, 4, then 5, 6, 7, 8, 9, 1, 0, 1, then 1, 1, 2, and 1, 1, 3. Okay, the answer is A, B, 1, E, 2, B, 0, 0, then double colon, then 1, 2, 3, 4, 5, 6, 7, 8, then 9, 1, 0, 1, 1, 1, 1, 2, and 1, 1, 1, 3. Check. It is correct. Okay. Let's try again in figure 6. This BB2, excuse me, EF12, EFF3, and 9125, and 1, and this is 101 because there is a leading 0, then all 1 again, then 101 because there is a leading 0 again. Okay, the answer is BB2E, EF12, EFF3, 9125, 111, then 101, then 111, and then 101. There is no answer that is 0, so we do not use double colon. Let's check. Okay, why? This is AB, sorry. Okay, it's correct. Figure 7. The answer is 1129, 1984, 2233, then 4455, 667, then 0, 0 again, then 101. Okay, let's check. Compress it. 1129 colon 1984, 2233, then 4455, 6677, then double colon because there is a 0, then 101. It is correct. Figure 8. Then 0, 0, 0, 0, then 101, and 111. So the answer is 111 double colon because there are a lot of zeros. Even though there is a 10, we can use double colon. So we can use double colon in a lot more zeros. So 101, then 111. Okay, let's check. It's correct. Next figure is in figure 9, 1031, 1976. Sorry. This 1976. 1, 2, 3, 4, 0, 101. So there are a lot of leading zeros, so you just type 1, then 2, then 3, 4, and then 0, then 101. Okay, 1031, 1976, 1, 2, 3, then 4, then double colon, then 101. Okay, it is correct. Last activity or figure is okay. There is an answer again, but sorry. It's 0, then 1, 2, 3, 4, 6, 6, 7, 8, 9, 101, then 0, then 3, 4, A, B. Okay. So as you see, there is zeros, lot of zeros here, then zero again in the last part. We can just use, we can only use double colon one time. We cannot use it two times because it will not be valid. So okay, double colon 1 2 3 4 6 6 7 8 9 1 0 1, then 0 because we cannot use double colon two times, then 34 A B. Okay, this is correct. So all the answers in this activity are correct. So we can move on to another activity. The last activity is, so there is an error in this part wherein it is white. The activity is identify types of IPv6 address. This is identify type of IPv6 address. I cannot just read this part. Okay. So the instruction is drag the IPv6 address type to the most appropriate description. Okay. First description is, it is a unique internet routable IPv6 address or dynamic or static. Okay, this is a global unicast. Because a global unicast is a dynamic or static wherein is whole. Like, okay, next. FE800:1. This is a link local. Next, 2001 colon then DB8 colon then ACAD double colon 1/64. It is a global unicast because it is a whole, because in this part, this is a IPv6 address, then this is the prefix length. So this is a global unicast. Next, typical IPv6 prefix used to indicate the network portion of the address. This is /64 because /64 is a 64 bits or 64, or this is the prefix length of the IPv6 addresses. Okay, next. Used to communicate with other devices on the same IPv6 subnet. This is a link local. A link local is used to communicate with other devices on the same IPv6 subnet. Let's check. So, the answers are correct. Okay, I finished all the activities in this chapter, chapter 7 IP addressing. Thank you for watching and see you on my next videos. Bye.